lessons. Today we want to discuss about spearman ranks correlation coefficient. Spearman ranks correlation coefficient is a method used for testing or measuring the strength of the relationship between two variables. That is, it is used to know whether two variables could vary. This means this spearman ranks is used to know if one variable increase, the other one tend to decrease or increase. And spearman ranks is denoted by the Greek letter rho, and rho or R is the formula used for the measuring of the strength of the relationship between two variables is given as rho is equal to 1 minus 6 sum of d square all over n into bracket n square minus 1 and close the bracket. So this is the formula used to calculate the strength between two variables. Now let's use these questions and use spearman's ranks to solve these questions. The question says that the following is the score obtained by 10 students in mathematics and physics. These are the scores of 10 students in mathematics and physics. To what extent is the knowledge of students in the two subjects related? This means we want to know the variable between these two subjects by every student. That is, if student A score 25 in mathematics, if student A score high score in mathematics, does that same student score high score also in physics or low score? So we want to know the weakness or the strength. We want to know the strength, either it is strong or weak or no correlations. So this is what you want to find out. And here we have 10 students. These are the score of 10 students. Spearman's ranks is based on ranking the variables. Now so let's use the scores in mathematics as what variable x, while the score in physics as variable y. So we are going to rank the score of every student in every subject matter. Now x, so the rank of x is equal to Rx, and the rank of y. So how are you going to rank them? You use the highest score as the first rank, that is the first position. You can also use from the lowest to the highest, so it's depending on you. But now let's use the highest score and we continue and so on and so forth. So the highest score in mathematics is 46, so that is the first position, and we have the next score. The next highest score is 44, the second position, and the next after 44 we have 37, the third position. The third position is the third position. 37, we also have 36, the fourth position. We have 36, we have 28 as the fifth position, and we have 26, the sixth position, 25 the 7th, and we have 24 as the 8th position, and 22 as the 9th, and 20 as the 10th. We use the same thing to rank those their score in physics. Here in physics, the highest score is 50. This is the first position. The second score, highest score, is 46, second position. And after 46, we have 36, the third position. We also have 33, the fourth position. The fourth position. We have 30. We have 30. 30 is the fifth position. The fifth position, 30. And we have 22, which is the sixth position. We have 21, the seventh position. And we have 18. No, we have 20, which is the eighth position. We have 18, the ninth position. And we have 16, the 10th positions. These are the rank. We have ranked the scores, Rx and Ry. Now, in the formula, we said rho is equal to 1 minus c sum of d square over n into bracket n square minus 1, and we close the brackets, minus 1. The difference in rank is D. D is known as the difference in rank. That is, D is equal to rank X minus rank Y. Whereas N is the number of observations, that is the number of candidates we have here. We have 10 students. This is our N. N is equal to 10. So this next thing we have to do is to find the difference. That is to find D. And we said D is equal to the what? The rank X minus the rank Y. So D is what is known as Rx minus Ry, rank X minus rank Y. And here we have 7 minus 4 is equal to 3. We have 6 minus 7 is equal to minus 1. We have 2 minus 2, we have 0. 4 minus 3, we have 1. And 1 minus 1, we have 0. And 8 minus 8, we also have 0 again. 9 minus 10, we have minus 1. And 10 minus 9, we have 1. And 5 minus 6, we have minus 1. And 3 minus 5, we have minus 2. These are the D. Our D is equal to the difference in rank. Now, our D square. Our D square, we find the D square. Here we have 3. This is D. 3 multiplied by 3 is equal to 9. And here we have minus 1 times minus 1. Minus 1 times minus 1 is equal to 1. 0 times 0. This is 0. 1 times 1 is 1. 0 times 0, 0. 0 times 0, 0. Minus 1 times minus 1 is equal to 1. 1 times 1, 1. Minus 1 times minus 1 is equal to 1. Minus 2 multiplied by minus 2 is equal to 4. Here we have our D square. Now, as you know, the formula is given as rho is equal to 1 6 minus 6 sum of d square all over n to bracket n square minus 1. Now we have 1 minus 6, the sum of d square. So we have to find the sum of all these products. 9 plus 1, we have 10, plus 1, 11, plus 1, 12, 13, 14, plus 8, plus 4 is equal to 18. So the sum of our d, it is what? 18. So we have bracket 18 here. Now over, we said our n is what? Is the sum of observation, the number of observation, the number of candidates we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n is equal to 10. We open the bracket, 10 square minus 1. We close the bracket. So we have 1 minus 6 multiplied by 18. So 6 multiplied by 18. 6 multiplied by 18. We have 6 multiplied by 18 is equal to 108. So we have 108 over, we have our 10, open the bracket, 10 multiplied by 10 is 10 square is equal to 100. And minus 1, we close the brackets. We continue with our formula. Continue. We have 1 equal to minus 108. We have 108. Now open the bracket, is equal to 10 in 100 minus 1. So we have 1 is equal to 1 minus 108 all over 10, open bracket, 99. So it's equal to 1 minus 108 over 10 multiplied by 99 is equal to 990. 990. So we're going to divide 108 divided by 980 divided by 990. Sorry, 990. We have is equal to 1 minus 0.109. We can approximate this is equal to 1 minus 0.11. So is equal to 1 minus 0.11. 1 minus 0.11 is 1 minus 0.11 is equal to 0.89, which is same thing as 0.9. So this is our correlation. This correlation is high. So we have high correlation here, positively high correlation. We have a positively high correlation. So this means a student that score high score in mathematics can also score high score in physics. That is, when the score increase in mathematics, the score also increase in physics. Thank you for watching. Bye, and see you in the next lessons. Thank you. You can ask your question in the comment sections. Bye.